No. 1. Y equals the square root of x squared plus x minus 2. Okay. You guys, tell me the domain. How do you find x-intercepts? Nope. Product sum? Yeah. Factor it. So, let's factor it. What do we get? So we get negative 2 and 1. Okay. Shh. Negative 2 and 1. Is this concave up parabola or down? So does it have to be perfectly sketched in order to figure this out? No. It's concave up. So you're going to have an x-intercept here and here, and it's going to look something like that. So we care about this part and this part that's above. So our domain is going to be x such that x is less than or equal to 2, or x is greater than or equal to 1. In interval notation, that is negative infinity to 2, or 1 to positive infinity. Good call. Why, what's scratched out? It's not scratched out. That's the part that matters. Because we need to, the top part matters. Because you can't have any values where it's below 0, because you can't take the square root of a negative. So you're taking the y values of this quadratic, and you're square rooting them. This is what we did in 30-1. We did this in 30-1. I promise you, you did. So the reason why is what you're doing is you're taking your y values and you're square rooting them. We can't square root any negatives, right? So these guys are out. Those guys are gonzo, Alfonso. Gonzo, Alfonso. All right. So, no, I'm keeping those. I wasn't scribbling them out. I was saying these are important. So the second thing we find is y-intercepts. You set what? It. What's it? Yeah. X equal to 0. So you're going to get y equals the square root of 0 squared plus 0 minus 2. And so you get the square root of negative 2. And what does that mean? So there are no y-intercepts. What about x-intercepts? Shh. X-intercept y equals to 0. For the x-intercepts, you're going to get 0 equals the square root of x squared plus x minus 2. Now, what some people might realize is that's the exact same numbers we found in this case for, it's not always the case, but in this case for our domain. Because how do we get rid of the square root sign, which we have to get rid of right away? Square it. And when we square 0, what happens? It stays 0. So it's 0 equals x squared plus x minus 2, which we've already factored. X plus 2, x minus 1, and we get x-intercepts at negative 2 and 1. Then we do critical numbers. The critical numbers for increase, decrease. How do we get our critical numbers for increase, decrease? First, Find the first derivative. So we have an equation of y equals x squared plus x minus 2, the whole square root of that. Now we can't do the derivative with a square root sign. What did we always do? Put it to the one hand. Then when we do the derivative of it, what do we have to do? Chain rule. So y prime equals 1/2 x squared plus x minus 2 to the negative 1/2. And then behind it, you get 2x plus 1. So if I rewrote this so I have positive exponents, I'd have 2x plus 1 on the top. And then 2x squared plus x minus 2 to the 1/2. And that's it for the first derivative. If you did the second derivative of this, you'd have to use quotient rule with chain rule. Yeah. So what are our critical numbers? Well, our critical numbers, you take the top and you solve it out. Everyone be okay with that. So our critical numbers for the top are negative 1/2, right? The critical numbers for the bottom, remember what you would do is you just take that x squared plus x minus 2 to the 1/2 and you set it equal to 0 and solve, correct? Do you agree? How do you get rid of the 1/2? You square it. When you square 0, it goes away. So remember when this was to a 2, we didn't really care. If it was to a 1/2, it didn't affect it. But we really need to find out where this equals 0. And we found this out 3 times. Well, 2 times, this would be the third. Where does this equal 0? Negative 2 and 1. So those are our critical numbers. Oh, goodness. So we get negative 2, negative 1/2, and 1. And I'm going to put dots on these because those aren't my test points. Then I'm going to pick negative 3, negative 1, 0, 2. Where do I plug them back in to find out if it's increasing or decreasing? The first derivative. So I'm going to go 2 times negative 3 plus 1 over 2 times negative 3 squared plus negative 3 minus 2 to the 1/2. So on the top, I'm going to get negative 6 plus 1, which is negative 5. And on the bottom, I'm going to get 2 times 9 minus 5, which is 4. 9 minus 5, which is 4. What's 4 to the 1/2? 2, because what's just to the 1/2 mean? Square root. So 2. And what are we going to get? Negative 5/4. So it's you do the other 3. So when you plug this one in, you're going to get nothing. It's going to be does not exist. When you plug in 0, you get does not exist. If you plugged in negative 1/2, you find out it actually isn't on there. It's not a critical number. And when you plug in 2, you're going to get a positive, so you're going to get increase. Because your graph looks like this. At 1, and then it goes like this. And at negative 2, and it goes like this. So it's decreasing to here and increasing to here. So you guys are going to try. Some radicals and rationals mixed as well. So it's page 317. And if it asks you to use guideline sketch curve, you're also going to have to find the second derivative and do concavities as well. That's an added. So if we did it on this one, we would have to do quotient rule with chain rule embedded in it. Keep that in mind. Okay, so page 317. Number 21. 25, 27, and 31. 21, 25, 27, and 31.